Deleting the nth node from the end is a classical interview problem and most people overcomplicate it. We are given a linked list and we need to delete nth node from the end. Let's understand the problem first. As we know, every linked list starts with a head pointer. So we have head here. If n is equal to 2, then we need to delete second node from the last, which is this 40 node. What are the possible scenarios? Input list can be empty, which means head pointer can be null. List can have a single node. Deleting the head node. In this case, if n is equal to 5, then head is the fifth node from the last and we need to delete this head node. N is greater than the length. Then in this case, the input is invalid. And deleting the last node, if n is equal to 1, then we need to delete the last node. We need to handle all of these cases, but let's build the simplest logic first. We can traverse the list to find its length. So in this case, length is 5, and then we can calculate the position from the start. If n is 2, which means we need to delete this second last node, then in this case we can find the position of this node. And then finally we can traverse the again and delete the node. But this approach will need 2 traversals and it's not efficient. So what is the better way? Can we do it in one pass? Let's build the logic for simple solution and then we will handle the edge cases one by one. We need to implement delete nth node from the end function, which accepts a head node as an input pointer and the nth position. And our function should return the new head node. Let's build logic step by step. The core idea is to use 2 pointer technique. We will use 2 pointers, a slow pointer and a fast pointer. Initially both pointers will point to the beginning of the list. So we have a slow pointer and fast pointer. If n is equal to 2, which means we need to delete this node, right? To delete this node, we need to reach its previous node, which means this node, node 30. How do we reach this node? The idea is very simple. Say if by traversal fast pointer reaches the end of the node, then our slow pointer should reach the 2 node before the end as n is 2. Once slow pointer reaches here, we can adjust the list to delete the node. Notice carefully here, the slow pointer is 2 steps behind the fast, right? Which means we need to move fast n steps ahead of slow. So to begin with, as n is 2, we will move fast 2 steps ahead. So fast will point here. This for loop moves the fast n steps ahead. For I is equal to 0, I is less than n, which means n step I plus plus, and in every iteration fast will point to the next node. Now we will increment slow and fast pointers until fast reaches the end of the list. Let's do that. Let's increment the slow pointer. Slow will point here. Let's increment the fast pointer. Let's increment the fast pointer. So fast will point here. Now again in next iteration, let's increment the slow. Slow will point here. Let's increment the fast. Fast will point here. Now notice carefully here. Slow pointer has reached the one node before the node which we want to delete, right? And in this case, fast next is null, which means until fast next is not null, we need to increment both slow and fast pointers. Look at this while loop now. While fast next is not null, fast is equal to fast dash greater than next and slow is equal to slow dash greater than next. Once we come out of this loop, we know for sure that slow will point to the one node before the node we want to delete, which is node 30 in this case. Now we want to delete this node 40. How can we delete this node 40? Let's use one temporary pointer temp, which will point to this node. So temp equal to slow's next. Slow's next is this node. So temp will point here. Now to delete this node, we need to break this link and slow's next should point here, right? Which means slow's next should point to temp's next. So let's do that. So slow's next equal to temp's next. With this, slow's next will point to the temp's next node. And after this, we need to free the memory of the node which we want to delete, which means free temp. And finally, we return the head. So this is very basic logic and it doesn't cover any corner cases. Now let's handle all cases one by one. What if input list is empty? Which means what if head is null? If head is null, we can simply return null and we don't want to process anything. If head is null, we will simply return. Now in this case, list length is 5, right? There are 5 nodes. What will happen if input is greater than 5? This code will crash because we are trying to move fast by n steps and fast pointer will point to null. And here we are trying to dereference the null pointer. So while moving fast pointer by n steps, if it points to null, then we simply return the head because the input length is invalid. Now what will happen if n is equal to 5? Think carefully. In this case, we need to delete this head node because this is the fifth node from the end, right? When this can happen in the code, once this for loop completes, if the fast pointer is null here, right, then we know that we need to delete the head node, because with this for loop after fifth iteration, fast will point to the null. What should we do if we want to delete this head node? Our new head node should become this node 20, and then we need to free up the memory for our previous head node. Let's do that. So if the fast pointer is null, what we need to do? First we'll save the head. So head will be saved in temp node. Then our new head should become heads next. So head equal to heads next. And then we free up the memory for the old head, which is temp. And finally we return the new head. This special handling should be added before this while loop here. Analyze this code yourself and make sure it works for all the scenarios. This two pointer pattern appears in many linked list problems. So mastering this is very important. Now that this pattern is clear, we can apply it to more advanced problems. So stay tuned.